Hello everyone, welcome to the iRobot Automation YouTube channel. In this video, I'm going to demonstrate how to use electromechanical relay simulation using FluidSIM software. Also, we'll have a discussion like what is exactly electromechanical relay or just a relay. What are the applications of it, and before that we'll also understand the function of relay and how it can be used in industrial automation applications to control the process. So let us discuss. Electromechanical relay is nothing but it's electrical switch. It is available both AC as well as DC, but as mentioned in the last video, we are going to discuss the relay of 24 volts. Okay, so relay is electrical switch. It is having two important components, that is coil and contacts. Electromagnetic coil is electromagnetic coil and contacts. So contacts we discussed in the last video, right? So contacts are operated only by electromagnetic force that is generated by the coil. So contacts normally open, normally close, then changeover type is available. Both normally open and normally close are combined. It's also called SPDT, single pole double throw contacts. Okay, so coil, this is the setup actually. So we'll have a discussion of relay. We'll understand function of relay using this diagram. This is better. The function of relay can be understood better in this diagram. See, there is a winding, that is coil, and coil, to energize the coil there is a supply. So here you can assume like a battery or any power source. In our case, in our discussion, say 5 volts or 24 volts. A PLC events 24 volts, microcontroller is 5 volts maximum. Okay, so that is called the control signal. That means after processing the data or after processing the instructions, PLC or microcontroller generates a control signal that is of small voltage. Okay, and this is a contact. So in this example we consider only normally open. I'll take up the another sketch where normally close is also there. Okay, so this is normally open. That means there are two circuits actually, a bulb circuit and the coil circuit. If coil circuit is closed, then what happens? The electromagnetic force is generated around the coil. So because of that, this contacts attracted towards the coil, and second circuit is also closed. It means bulb circuit will be closed, but bulb circuit having a high voltage supply or high power circuit. So in that case 24 volts, or you can take it 230 volts AC bulb. Then what we're doing is actually using relay. See, whatever square box or rectangular box shown, that is actually the relay. The relay will have coil and contacts. When coil is energized, contacts become changed. That means open to close, close to open. So since we are using open contact here, it will be closed when coil is energized. So this is the application. But to understand the function wise is whenever coil is energized in the relay, contact will be changed from open to close, close to open. That is the function. And application is when one important application is, say for example, switching the high voltage circuit using low voltage. Okay, that is also important application, because PLC or microcontroller directly high power motor or high power bulb cannot be given directly. So in that case, relay acts like an interface between the controller and the actuator. so that it will, voltage problem will be solved. Okay, power some actuators like very high power motor, we cannot drive directly from PLC or microcontroller. So in that case, this relay is going to help us, where it is going to switch the high power circuit or switch off the high power circuit. Okay, so that is the application. But how a relay can be used in industrial automation for switching application, like switch on motor, switch off motor, switch on heater, then light indicator. So in automation, the switching application mainly can be taken care by the relay. A series of relay, if you use it, then still complete automation is possible without using PLC also. So that is what we are talking about. To understand relay circuits or relay control system, so function of relay you have to understand first. Okay, I hope you understood the function of relay here. There is one more diagram. As I mentioned earlier, contacts three types: normally open, normally close, and changeover type. This is a changeover type contacts. Okay, so this left hand side is coil is de-energized and this one is energized. Okay, right hand side is energized. That means there is a coil here, and coil is having two terminals, and armature is there, and three pins are there, like this. Three pins are important. Say here. Generally, this normally open is indicated by pin number 3 and 4. Normally close indicated by 1 and 2. When you have both normally open and normally close, 1 and 3 will be common. 3 is not mentioned here. That means 1 and 2 means normally close, 1 and 4 means normally open. So this is what the number is used. Numbers are very important, especially when you are doing the wiring. Okay, say for example, you are a design engineer, you have designed the circuit, but when you give it to the operator level, without numbering, it's very difficult to wire it. It means operator will have a difficulty in actually doing the wiring. Okay, so numbers are important so that operator will follow the numbers. Now come back to the discussion here. So this is a middle contact is a moving pin, actually moving pin, and a common pin. And since it is de-energized, coil is de-energized, the middle pin and the bottom pin actually already have a contact, and it is normally closed. And middle pin and the top side pin is not having contact, it is normally open. But when you energize coil by supplying power to the coil, electromagnet is created. Then what happens? Armature attracted towards the coil, and there is a vertical plunger, means bottom pin having a through hole actually. So a vertical plunger will move up and pushing the middle pin towards the top side and loses contact with bottom side. So these two contact becomes temporarily normally close, and these two contacts become normally open. Okay, so this is actually switching. So when coil is de-energized, when you cut off the supply to the coil, again it comes to normal position because there will be spring. That spring is not shown here, but it will come to normal position. Okay, there is a hinge point is shown here, so it will come to normal position. This is a normal condition, this is off condition, this is on condition. That means when coil is off, this is the condition; when coil is on, this is the condition. So finally what we can understand is, when coil is energized in the relay, electromechanical relay, what happens? Open contact becomes closed, closed contact becomes open. When coil is de-energized, it becomes to the normal condition. Okay, so this is the function of relay. So we'll understand by this way also. See here, this is another way you can understand. There is a middle contact is there, so that is the common terminal. So it is having three terminals here, right? NC contact, normally open contact. So what happens when coil is energized? So here coil is shown AC, but it's okay, DC also. We're discussing only DC here. When coil is energized, middle contact will move away from NC contact and makes contact with NO contact. Okay, so this is the understanding. And pins are here where we can connect it to load. Sometimes at the time of commissioning, Okay, so assume that you don't have electrical supply, still you want to operate relay. So manual override function will be there, mechanism is there, where manually you can move the actuator, means armature. Okay, so that you can manually switch on the relay without having electrical supply. So that is called manual override function. Every relay will have that function. And what voltage we supply to the coil, that is called input side, and coils are means contacts are nothing but the power side. The one important observation you have to make it here is the input side is entirely different than the power side, means there is no connection. This can be 5 volts, this can be 440 volts or 230 volts, like that. Okay, high voltage, very high voltage is possible, so it's not related. So that is why many application we use relay to switch high power circuits or high voltage circuits using low voltage or low power circuit. Okay, I hope you understood the function of relay. So now, using FluidSIM software, how we can simulate the relay function. And this is important, AC as well as DC, but we use 24 volt DC relay in throughout the discussions of internship. Okay, let us discuss on FluidSIM software. Double click on FluidSIM software. Uh, Take a new file. Okay, and go to electrical controls IEC standard, and first of all you should take the power supply, that is 24 volts. Power lines you have to drag and drop onto the screen. Then relay, in the relay section you can find relay, actually means relay coil is there. Okay, actually there are two types of coil, relay coil AC and relay coil DC. So you should take DC or relay, just relay coil is there. Relay, don't take relay coil AC, it will not work for the DC supply. So now switch is also required to demonstrate the function of relay. So we'll take a switch here, normally open, push button type. And relay means what? There will be a coil, this is a symbol of coil. Coil will have two terminals. So we are energizing the coil with the help of switch. This switch, I'll name it as, double click on the switch, and then in the identification you type S1, that is a tag name or variable name in the software. And every relay will have, say for example in my circuit 10 relays are there, so how can I differentiate? There should be a name, right? So double click on the coil, and entire relay box name is K1. Okay, K1 is the entire relay box. Relay means what? Coil and contacts. So relay means coil and contact. So contact we should take it. So it is available in switches, general switches. You have to go to the general, not manually operated. It is general switches where normally open contact is there, or it is also called make switch. So normally open contact. And okay, before that we'll take changeover type. Okay, changeover switch will take it. Both open contact is also there, closed contact is also there. And I'll rotate. I want common terminal upside, so I rotate it. And common terminal is given to the 24 volt supply as a common pin. And to demonstrate, I will take the actuator. Actuator motor is there, solenoid is there, but I want to have the light indicator. Let us see. Yeah, light indicator lamp is there, and I'll take one motor. Motor is connected to normally open. 1 and 4 means normally open, 1 and 2 means normally close. Other terminals of motor and lamp connected to 0 volts. Motor, I will name it as motor or just M1. It's a motor 1, and this one is a lamp, so name it as lamp. Okay, so go to the simulation by pressing the play button, that is start button. See, by default, okay, 1 minute, this text is disturbing actually. Yeah, see, by default lamp is on. Why? Because we are connected to normally close. Okay, one more thing, this contact should be connected to which relay box, which coil, right? That is also important. So double click, since it is software we have to link it, and you have to main component, the drop down menu is there, then select K1. If you have 10 relays, then 10 relay names will be available here. You can select whichever coil. So K1 selected, okay. So now it belongs to K1 relay box or K1 coil. So now if I press the switch, see, now lamp is already on but motor is not on. But when you operate the switch, there is a supply of power to the coil. When coil is on, open become close and close become open, so motor is on but lamp is off. But if you release the switch, again it changes over to normal condition. This is on, off. Okay, so this is what function of relay. When coil is energized, open contact becomes close, close contact becomes open, which belong to that coil. Okay, the contacts will get changed over when its coil is energized. That is a main function. So I hope you understood the function of relay. Application, we'll have a discussion. Application is, say for example, for that I will take normally open contact. Okay, we'll go to the power supply. Okay, only 24 volts is available on this. Okay, in this high voltage means different voltage circuit is not there. Another software is there, so I'll discuss in the class. Okay, there is the application. So this is how you can use relay. I'll take normally open contact, only normally open contact, and you can connect it to a motor. And this, double click on this and then link it to K1. K1 is entire relay box. So this is using only normally open contact. When coil is on, electromagnetic force will make open contact to close, so that motor is on. Okay, there is another discussion here. In practical application, a coil can have a normally open contact and normally closed contact, sometimes separately normally open, normally close. And this is actually single pole double throw SPDT. SPDT contacts are used in our laboratory, that means Bosch Rexroth laboratory. Relays are using the SPDT contacts, single pole double throw. This type of contacts are used. This is what practically you can see in the laboratory. A single coil is there. Coil is one, but SPDT contacts are 4 in number. We call as 4 changeover relay box. So 1 and 2 means normally close, 1 and 4 means normally open. But here, since there are 4 sets of contacts, the first number means set number and pin number. So 1 means set number 1, pin number 1, set number 1, pin number 2. Like that you should read. So if you summarize, then this relay box has got 4 normally open contacts and 4 normally closed contacts. Okay, so let us simulate. That means the working principle is like when coil is on, all 4 contacts will get changeover at the same time, not one by one. There is no sequence here. Sir, what does application means? Like sometimes we want to switch on 2 motors, we want to switch off 2 motors. That means totally 4 actuators are there. So one control signal, but I want to switch on 2 motors, I want to switch off 2 motors, or if you want to switch on all 4 motors with one signal, so in that case this kind of relay boxes are used. And also it is especially automation, looping, then logical operations like AND gate, OR gate, basic gates, and combination of logic gates are possible with the help of this multiple contacts. Okay, so in market 1 changeover, 2 changeover, 4 changeover, and higher changeover also it's available in the market. So this is in our laboratory entire discussion we are using 4 changeover relay box. So let us simulate this also. Say for example I'll take changeover contact that is available in general switches. This is one SPDT, so I have to rotate this. Okay, so like this I will take 4 in number. This is one set, sorry, second and third, and this is fourth one. And say for example 4 different motors are there. But 2 motors I'm connecting to normally open and 2 motors I'm connecting to normally close. This is just a case we are assuming. You can connect it to open as well as close. All 4 open, all 4 close also possible. But what is important thing is we should link that these contacts are belonging to which coil? K1 coil. So double click and then select K1. This is K1. K1. Okay. Now go to simulation. When you operate switch, see already we should name this motors also. This is M1 and this is M2. M3. F. So we've taken 4 motors, right? M3 and M4 already on. See now M1, M2 is on, but M3 and M4 is off. These are practical applications where you can switch on multiple outputs by using only one control signal. Logic gates I will take up in the next video. We can use relay to perform logical operations like AND gate, OR gate, NAND. So all logic gates are possible, and there is one more special function, is signal storage is possible. So in the next video we'll have a discussion. Thank you everyone. Thank you for watching this. Please subscribe to my channel. Thank you.